Okay, just another update on the self-balancing robot platform that I've been putting together. So as you can see, I have two motors connected now. The wiring has become a little bit more complex, but not too much. I still have my buck converter. I've got my bench supply. I've got that currently set to 14.1 volts with 0.8 amps current limits. Everything's on right now, and so I guess probably the easiest way to show you what's going on is I'm able to monitor over serial because I've fixed my power setup here, so I can still power and monitor over serial on the board, and I can get action on the motors. So it's not that exciting, but there's actually a little PD loop in there, and that's all working. So what I've done is I've wired up the ESP32, which is just here. I've wired that up and connected that to my MPU6050, and that is feeding accelerometer and gyroscope data. So it's a 6-axis IMU. That's feeding that into the ESP32. I've got two motor drivers now, both connected to different data pins on the ESP32 for direction and for step pulses. I've got two caps here, supposedly protecting any weird power issues to the drivers. And so this is now basically my 12 or 14.1 volt rail. This turns it into a 5 volt rail, which I'm not currently using right now because I'm powering the ESP over USB. And then I've just converted this positive here, into a 3.3 volt rail. So I have 5 volts coming in here or from the buck converter, and then that feeds, or that 3.3 rail comes out of the ESP, and then I tap off to that to various logic pins and other things that I need to the stepper driver boards and the IMU and that sort of thing. So I've got consistent logic level across everything at 3.3 volts. So that's really great. So that all just works, which is kind of cool. Okay. It's not that exciting yet, but I do have damping. So what I've been doing is, generating all this serial output, I'll just stop that here for a sec. What I've been doing is I've got a little Python program that plots that data. And this has been really helpful for me to build an intuition for what's going on with the PD loop and the sort of the control system. It's very primitive at the moment, but what you can see here is I've got, I'm plotting a bunch of stuff around pitch and target tilt and what have you. I've got two terms that I'm printing here. I've got a P term and a D term, of course. So that is basically my simple control system, and then I have an output here which I call U, and that is effectively driving the motors. I've got a stepper frequency here. So basically what I'm able to do is I'm able to see when things are enabled, whether I got data from the IMU, whether I have hit a safety stop issue, what direction things are going in, my timing is consistent, a stop reason. So basically I can sort of start to tune the P&D gain and then work out how the system is performing as a result of that. I still have Bluetooth working, so BLE is still part of the picture. I can command that, and that just sets a sort of an attitude bias. It sets, I think I call it tilt bias or something like that, or target tilt, and then the idea is that the PD control loop is responsible for adjusting the motors to suit. So I'm not driving directly, of course, from the BLE user commands. I'm just setting some, I guess, environmental factors, if you like, for the PD loop, and the control system there works. So that's where we're at. Some good progress. It's really good to get the IMU working. I'm using the DMP on the MPU6050, as I mentioned, and I'm using a I2C dev library, which is great, and that gives me sensor fusion, so I'm able to get predictable, and I'm able to remove noise from the signals that I'm getting from the IMU, and I'm able to get good pitch and what have you sort of readings, so that's helpful. reduces the maths, puts the load back onto the DMP on the IMU board. It means that the microprocessor isn't having to deal with that. So yeah, happy days. It's working quite well. And it's only drawing 0.4 amps at 14 volts. And that all works rather nicely. So the update in the next one will probably be putting together the board. So I've built, sorry, the robot frame. So I've bought what I need to start putting together the robot frame. I'm just going to follow the same design that that the Yet Another Balancing Robot blog had, which was building out of plywood. So there's no 3D printing or anything like that. That'll just keep things really simple and easy. And then I should have that up and running and have the 2 motors running on the frame for the next update. I won't promise to have anything balancing, but I guess we'll see. And in a week's time, if I can build the frame, probably have this converted to put that on a perf board of some sort, and then see what I can do in terms of driving attitude of this balancing robot and see if I can bring it up. So that's where we're at. Thanks so much everyone for following along. See you in a week.